All right, let's set the scene. You know that feeling. It's exam season. The pressure is absolutely on.
So you're all huddled up with your friends, and there's always that one person, right? The one with the perfect notes. We're talking the golden ticket, the key to acing that final exam.
And of course, what happens next? Everyone needs a copy. So the photocopier is working overtime, phones are out snapping pictures, and just like that, one set of notes becomes 5, then 10 copies, or as we call them, replicas, flying around the entire study group. But wait, plot twist. The original note-taker spots a mistake and fixes it. Oh, and they add this amazing, super important summary for the last chapter. The problem, only their copy gets updated. Meanwhile, your buddy across the table is cramming from the old, now incorrect version. They have no idea. You can just feel the chaos brewing, can't you? And that's the thing, right? Copying is easy. Anyone can do that. But keeping all those copies updated, that's where things get seriously messy. This is how someone ends up failing an exam, all because they were studying from outdated info. Well, believe it or not, this exact same problem is what Replica Management is all about. Not for students, of course, but for the huge, complex, distributed systems that power pretty much everything in our digital lives. So, let's peel back the layers on this whole note-copying mess. What is Replica Management, really? Think of it like this. Replica Management is basically the set of rules for controlling all those data copies, or replicas. It's the manager that decides, okay, where are we going to create these copies? Where are we going to place them? And the big one, how on earth are we going to keep them all updated and in sync? So first things first, the system has to figure out where should we even put these copies, and that leads us to the strategy of placement. Now, the logic here is actually super simple. Let's say you've got a ton of users in India. It makes no sense for them to have to get their data from a server all the way in the US, right? That's going to be slow. So what do? You put a copy, a replica, of that data right there in India. By closing that physical distance, everything feels way, way faster for them. I mean, let's be real. Sticking all your replicas in one spot is just a recipe for disaster. It's basically the same as everyone giving their notes to one friend to hold, and then that friend gets sick on exam day. Yikes. You gotta spread them out. All right, so our copies are smartly placed around the world. Awesome. But now we hit the really, really hard part. How do you make sure that when one copy gets an update, all the others get the exact same update? This is where we talk about updates and propagation. So you've got two main game plans here. First, there's the immediate update. This is exactly what it sounds like. The second a change happens, every single replica gets updated right away. This gives you amazing consistency, but man, it can slow the whole system down. The other option? The lazy update. With this one, the updates roll out after a bit of a delay. It's way faster, but you guessed it, there's a catch. You get this period of temporary inconsistency. Which brings us back to our notes analogy, because this is perfect. A lazy update is pretty much you saying, I'll copy down those changes later. It feels fine at the time, right? But then it's the night before the exam, and you realize you're studying from notes that are a week old. Yeah, not great. Okay, so how do these updates actually get from point A to point B? Well, you can either push or pull. In a push-based system, the main server is super proactive. As soon as it has an update, it just shoves it out to all the replicas. Like, here you go, new data. In a pull-based system, it's the other way around. The replicas are the ones who have to ask. They periodically check in with the main server like, hey, got anything new for me? They pull the data when they're ready for it. You know, all of these decisions, where to put the copies, how to update them, they all boil down to one of the biggest challenges in all of distributed systems. It's this constant, fundamental tug-of-war between being fast and being correct. Here's the bottom line, and it's something you just can't get around. If you demand perfect consistency, where every single user sees the exact same data at the exact same time, your system is going to be slower, period. If you prioritize raw speed and performance, you have to be okay with the fact that sometimes, for a little while, things might be a bit out of sync. It's a trade-off. You can't have your cake and eat it too. And isn't that just the classic student's choice? It's like, do you study slowly all semester and make sure you really get it? Or do you pull an all-nighter, cram everything in, and just hope for a little bit of luck on the exam? Okay, let's wrap this all up. Time for the exam-ready cheat sheet. This is the stuff you'll want to lock in your brain. So you might be thinking, wow, this sounds super complicated. Why even bother? Well, the payoff is massive. You get way faster access for your users, you get high availability, which means the system keeps on chugging even if a server goes down, and you get way better fault tolerance overall.
But let's be fair, it's not all sunshine and rainbows. There are some real downsides. Managing all this is incredibly complex. There's always that nagging risk of data inconsistency, and yet it generates a whole lot more network traffic.
Okay, pencils ready? If your exam asks you to define this, here's your perfect 10 out of 10 answer. Replica management refers to the techniques used to manage data copies in a distributed system. It includes replica placement, update strategies, and propagation methods to balance consistency, performance, and availability. And hey, if you need a super simple way to remember the 3 key parts, just think of a puppy. P-U-P. P for placement, where the copies live, U for update, how they stay fresh, and P for propagation, how the news of an update spreads. P-U-P. Easy, right? So when you boil it all down, what's the big takeaway? In distributed systems, making a copy of something, that's a piece of cake. But making sure that every single one of those copies is telling the exact same story at the exact same time, that is the real challenge.